Welcome to lecture series on data structures. In today's lecture series, we are going to discuss about another tree data structure called as binary search tree. So previously we have seen about what binary tree is, right? So as the name indicates, each node in the tree will have only two branches or two child nodes. So if a node in a tree has maximum of 0, 1 or 2 child nodes, then that particular tree is called as binary search tree. Sorry, binary tree. So binary search tree is a binary tree where all the values in the left subtree are less than the root and all the values in the right subtree are greater than the root. Such kind of binary tree is called as binary search tree. Now, look at this following example sorry, where Tom is trying to uh, hold a data set. So he want to add more data to the data set that he has, but he wants all the data to be stored in a sorted manner, in specific in a hierarchical way. So what is a way that the Tom can use to arrange his data in the data set? If it is a sequential order, he can either use stack or or queue or list. Since it is mentioned as hierarchical way, he cannot use any of the mentioned data structures. So the only option left for him is to use tree data structure for storing the data set in a hierarchical order. Now look at this particular tree. This is a perfect example for binary search tree. So a binary search tree is a binary tree where every node contains smaller values on the left subtree and larger values on the right subtree. So all the values in the left subtree are less than or equal to the root and all the values on the right subtree are greater than the root. Here is an example for binary search tree. Now look at this particular tree. What is your root node? The root node contains the value 45. Left subtree contains values 20, 15 and 40. So all the values in the left subtree are less than the root, which is 45. Right subtree contains values 50, 65, 60 and 70. All the values on the right subtree are greater than the root 45. Now if in case there is a value called as 45 that need to be stored in this particular tree, so you will compare 45 with the root node. Again, the root node has a value 45. So if the value that you want to store is equal to the root node, that particular value will be stored in the left subtree. So you will not store in the right subtree. If any value is equal to the root node, the value has to be stored in the left subtree. Here are some of the applications of binary search tree. Binary search tree is used for calculating or constructing expression trees. It is also used for expressing the arithmetic expression. For dynamic sorting, binary search tree is a perfect example. And for virtual management and IP address indexing, binary search tree can be best utilized. Here are some of the assessment. You are given three examples. We have three examples A, B and C. Out of these three examples, you have to find which one is the binary search tree. Now let us see which tree is satisfying the properties of binary search tree. Once again. So now let us see which tree is satisfying the properties of binary search tree. Look at the first example A. All the values in the right subtree 7, 2, 6, 5, 11 are less than the root. Here the root value is 3. So this condition is false. Hence A is not a binary search tree. Now look at the second example. All the values in the left subtree 1, 3, 6, 4, 7 are less than the root, which is 8. Yes. And all the values on the right subtree 10, 13, 14 are greater than the root. Again, the root is 8. Again, the condition is satisfied. So this is a binary search tree. Now look at the third example. Here the root node is 36. All the values on left subtree 13, 15, 21 and 29 are less than the root. True. However, all the values on the right subtree. Here, right subtree contains a value 36 which is equal to the value on the root node. So this does not satisfy the condition of binary search tree. Hence, C is not a binary search tree. Only out of these three examples, only B is binary search tree. So in the next lecture video, we will discuss how to insert a value into a binary search tree, and while deleting a value from the binary search tree, what are the three conditions we need to look for, and how to create a node in a binary search tree, and how to display the values as we traverse the node. So far you have understood what is binary search tree, and what are the various conditions for a binary tree to become a binary search tree. So hope you have understood all those, and we have seen the application of binary search tree. We have seen some of the examples for binary search tree. So thanks for watching. Keep watching. In the next video, we will discuss about the conditions for inserting a node and for deleting a node from a binary search tree. Thanks for watching.